Today, we're going to go small to understand something really big. We're looking at a component that's right at the heart of modern industrial power, the basic semiconductor BMF80R12RA3 silicon carbide module. It's a tiny powerhouse that's totally changing the game for efficiency and reliability.
You know, it all really boils down to one huge question. In a world that runs on electricity, from massive factories to super high-tech manufacturing, how do we get more power where we need it and waste less of it along the way? The push for better efficiency, it never stops. And the answer, it turns out, isn't about building bigger machines. It's about building with fundamentally better materials. The solution really begins right here, on a silicon carbide wafer, where the next generation of power electronics is literally born.
So let's start with the core challenge here. Why is a component like this so incredibly necessary in the first place?
Okay, think about it like this. Every single time electricity flows through a component, a little bit of that energy gets lost as heat. It's just physics. Now, in your phone, that's a tiny, tiny amount. But in an industrial welder or a giant factory inverter, that wasted energy adds up to huge losses, which means you need bigger, more expensive cooling systems, and you get lower performance. The real challenge is to cut that waste down to almost nothing.
So how do you even begin to fight all that wasted energy? Well, you change the rules of the game with a completely new material. Let's talk about silicon carbide.
Silicon carbide, or SiC as we call it, is a total breakthrough. I mean, compared to the traditional silicon that has powered electronics for decades, SiC can handle way higher voltages and temperatures. It can switch on and off much, much faster, and it does all of that with way less energy loss. It's just fundamentally better for the high-power jobs. And of course, making components from this advanced material requires an extraordinary level of precision and quality. This isn't something you can just whip up in a garage, right? It takes these incredible state-of-the-art facilities to turn raw SiC wafers into the kind of reliable, high-performance modules that industry truly depends on.
All right, we've set the stage. We know the why. Now, let's meet the component that puts all this amazing theory into practice.
And here it is, the BMF80R12R3. It might not look like a world changer, but this little compact module is a serious piece of engineering, designed to efficiently handle and control huge amounts of electrical power.
So what's the big deal? What's under the hood? Well, it's built on BASIC's third-generation chip technology, so it's packed with the latest performance upgrades. It has incredibly low loss, both when it's on and when it's switching, which means, you guessed it, way better efficiency. It's built tough with advanced materials for high reliability, it has its own temperature sensor built right in, and it's even designed to be installed in a couple of different ways, which is super versatile.
Okay, the feature list is great, but let's get into the nitty-gritty. Let's look at the hard numbers. This is where we see just how well this module really performs when the pressure is on. This number is key. 15 milliohms. That's the module's on resistance. Think of it like electrical friction. An incredibly low number like this means electricity just glides right through with very little resistance, which means very little energy gets wasted as heat. It's awesome!
And just so we're all on the same page, this RDS on, or on resistance, is probably the most critical metric for efficiency in a power device like this. The rule is simple. The lower the number, the less power you lose. That means the whole system can run cooler and much more efficiently. Lower is always better.
And this is where it gets really impressive. Even when this module heats up to a blistering 175 degrees Celsius, that's 347 degrees Fahrenheit, by the way, the on resistance only creeps up to about 28 milliohms. That is fantastic stability. It proves this thing can maintain its incredible efficiency even in the toughest, hottest industrial environments. Now this number here, this is all about safety and just toughness. So while this is a 1200-volt module, it's actually tested to handle breakdown voltages of around 1600 volts. That massive safety margin means it can take unexpected voltage spikes in stride, making it incredibly robust and reliable out in the real world. And we can't say this enough, that ability to operate at 175 degrees Celsius is a true game changer. Industrial environments are harsh, they're hot. A component that not only survives but actually thrives at these temperatures is a component you know you can depend on day in and day out.
So, we've got all this amazing performance, but where does it all actually get put to work? Let's check out the real-world applications. This module is designed for the heavy hitters of industry. We're talking high-end industrial welders that need precise, super efficient power control. We're talking induction heating systems that can literally melt metal, industrial inverters that drive massive motors, and power supplies for electroplating. These are all places where efficiency and rock-solid reliability are absolutely critical.
The secret sauce behind a lot of this is a circuit called a half-bridge. Think of it as the fundamental building block, or a Lego brick, for controlling power in those heavy-duty applications. And the BMF80R12RA3 module, well, it contains this exact configuration, basically acting as a powerful and efficient switch right out of the box.
And you know, it all comes back to a core philosophy of quality. The manufacturer talks about their deep experience and an automotive-grade design approach. What does that really mean? It means this isn't just a powerful component. It's a component built from the ground up with one goal in mind: being exceptionally reliable for the long haul.
So there you have it. A tiny, super powerful component built on advanced materials can make our industrial world vastly more efficient. The real question is, as these components get even better, shrinking in size while growing in power, what incredible new technologies will they make possible next? That's what makes this whole space so exciting to watch. Thanks for diving in with me today.